Okay, now let's look at how to design basic gates from NAND gates, minimum number of NAND gates. Obviously, because if more number of NAND gates we will use, means we are consuming more gates, we are consuming more hardware, which is not good. Hence, we will figure out that minimum number of NAND gates required for basic gates, okay, to make basic gates. So first basic gate is NOT gate, just to connect the two inputs together, and both the inputs will have same input, means both the terminals will have same input, and what you will get is a NOT gate. Okay, so this is basically a dot a bar. Okay, this is a dot a b is equal to a only, so it is a bar. So that's a boolean what I say, boolean expression, boolean laws I should say. This is one of the laws, so a boolean laws. So I will be covering it just soon, we will be covering it. Just I want to show you that how you can make basic gates. Okay, so boolean laws, maybe I should have first taught you this, but still next we will see that. Boolean laws, here this is the NAND gate. Okay, only one NAND gate is required to make one NOT gate. Okay, then second, if you will see AND gate, here a and b are given to this NAND gate, so the output will be a dot b bar. What we want is a dot b, so just connect this NOT gate here. What you will get is a dot b. So we are only using NAND gate to implement this functionality, only using NAND gate to implement this functionality. Now here it requires two NAND gate. Moving on to the third one is OR gate. So what we want is a plus b. Now we try to mold the expression of NAND gate so that we will get this a plus b. What you can do is use De Morgan's law. Again, it's one of the Boolean laws, but I have told you this before. Okay, so here I am giving a bar, so you can see a is given, here a bar will be there, here b is there, so here b bar will be there. Now NAND gate will make a bar dot b bar whole bar. Now this is equivalent to a plus b because of De Morgan's law. A bar dot b bar whole bar is equal to a double bar plus b double bar. This is De Morgan's law. Now a double bar means you are doing complement two times. Okay, if 1 you will complement, it will become 0. If 0 I will again be complemented, it will become 1. That is what it means by a double bar. So a is become a bar, then a double bar means a only. Okay, that is a. So if you are complementing something, if you will again complement the same, then you will get the original number. Okay, so that is the logic. So that's why this is equivalent to a and this is equivalent to b, and this is OR gate. So total 3 NAND gates are required to make OR functionality. Okay, so 1 2 3. Now then we will see later on that how to implement any function with minimum number of NAND gates, but first I think I should include how to make NOT AND and OR gate by this NOR gates, and then also I have to include Boolean laws. Then we will see that. Okay, how to implement any function with NAND and NOR, minimum number of NAND and NOR gates. Okay.